Okay, let's look at this. While visiting Oregon, you see a shirt with a $15 price tag on it. There's an 18% off sale. So what's the final price you end up needing to pay for this shirt? By the way, please note that Oregon has no sales tax. This is actually helpful because if we also had sales tax, then it's adding a layer of confusion on top of that. So we can deal with that later. Let's stick to the simpler case where there's a percentage going on, but it's a discount. And if we wanted to talk about discount with a sales tax as well, that should be saved for a future question, right? So here, $15 original price, but you're getting 18% off. So that's we sort of separately say let's compute 18% of $15 and then subtract that away from 15 because that's stuff you don't have to pay, so it makes sense to subtract, right? And we're done. I mean, whatever number that is, however that simplifies into a calculator, I think on paper I would just prefer an answer that looks like this. Why waste time punching that into a calculator? Just write down what you'd punch into a calculator anyway, and just have this as a final answer. The point, though, of this question we didn't need to solve for any variable. We didn't set up a variable inside an equation, but this shows us what the model for an 18% discount should be. You should take the pre-discount amount, or the price before the discount, the original price, subtract 18% of that same number, the price before discount. That will be the new price, or the price after the discount is applied, or the discounted price, right? So you'll notice here there is no mistake. 15, like in 15.00 appears twice in the answer that we saw, and that informs us the price before discount appears in two spots in the model, right? So it appears once before the minus sign, and then that price before discount appears a second time as it's being multiplied by 0.18. Now this is the model to use, and in the question we just looked at, the price before discount was known, so all of the quantities on the left side were known, and so that all was an expression that equaled the thing that the question asked, namely the price after discount, so we didn't really have to solve for anything in an equation. Right? So again, the previous question, we really applied this model, or rather used that to lead up to this model, and we knew the price before discount. Now look at this next question. While visiting Montana, that's another state with no sales tax, a store has an 18% off sale, and if you have $15 in your pockets to spend, what is the maximal price according to a price tag of an item you can afford? So now what's going on is this $15 is representing the price after discount, right? There's an 18% off everything in the store. So the price before the discount, we'll use B, I guess, for before. We don't know that, right? That the price before discount, that's what's on the price tags. I mean, stores are not going around and updating price tags for when there's a sale and when there's not a sale. They just leave the price tags the way they are and kind of just put signs up to say, oh, look at the price tag amount and we're given an 18% discount, right? So that they can't update that all the time. So the amount on the price tag, or the price before discount, is B. That's unknown, and that will take place of where it says price before discount in the two spots. So B minus 0.18 times B. And then the price after discount is what's known, right? So 15.00 isn't the price after discount for this question, whereas 15.00 was plugged into the two places that was the price before discount in the previous question. And we do it this way here because, well, we don't know the price before discount. It appears twice, and we're trying to solve for B, right? So we'll factor out B, divide by what's in parentheses on both sides. And so the conclusion here is that the price tag, the original amount of whatever item we can try to find, is we're looking for an item where the price tag, or the original amount, the price before the discount, should be 15 over 1 minus 0.18. That number in dollars. Again, no need to put this in a calculator. I think writing a number like this saves time. People tend to write things like this down anyway before punching into a calculator, so why not just save time by not needing to punch into a calculator? Just a conclusion that's written literally like this line where the happy face is, that's a great conclusion in my opinion. Okay, the last two questions both use this model for an 18% discount. It's just in the first of those questions, the $15 was the price before discount, so it got plugged in right there and right there. In the second question, the $15 was the price after the discount, so it got plugged in right here after the equal sign. And so the price before discount was the unknown, and we needed variables. In the former question, strictly speaking, we could have had a variable for the price after discount. Maybe we could have called it A for after, but that would have just replaced where the question mark is, and there'd be nothing to solve. There's nothing you'd have to do on both sides. We're basically done. So somehow, in the former question, where you could use a variable where the question mark is, but we'd already have solved, and the point is the expression that's to the left of the equal sign is already the number we need. It's just for the latter question, the thing that we needed was the price before discount, and we didn't know it, and it needed to appear in two places to set up an equation so that we could, after setting it up, solve the equation. But how would you set up this equation like this? How could you set up this equation if you never said what the variable was in the first place, right? So in both of these problems, you'll notice that there's a computation of 18% of the price before discount. Now, in the former question, that was subtracting 0.18 times 15.00, because 15 was the price before discount in the former question. In the latter question, we ended up subtracting 0.18 times p, because p was p or b was, the variable was representing the price before discount. Okay, summary of some ideas here. Let's say now we had 12% as a rate. Instead of memorizing the price before plus 0.12 times price before equals price after for tax versus price before minus 0.12 times price before equals price after for discount, I'd rather, instead of you saying you need to memorize these two things separately, just really think about whether adding or subtracting is the most appropriate thing, right? Think about how for tax, you have to pay the price before tax, and then you have to pay something in addition to the restaurant or the store or whatever, that they're going to forward that money onto the government. Effectively, it's money that you pay in addition that goes to the government. Versus for a discount, the reason it's a minus is because you take the original price and then we adjust to say there's a certain amount that we no longer have to pay. It's almost like if you didn't know there was a discount, you'd put the original amount of money on the table and then they'd give you money back and you go, "What's this?" And they'd say, well, there's a sale, there's a discount, so you don't have to pay this, so we're returning you some money. So it makes sense that there's a minus sign there, yeah? Okay, and most importantly, think about what you're computing 12% of, right? That's the key thing. It's often an error that's made that, you need to compute, say, 12% of the price before instead of computing 12% of the price after. Just because it's a known number doesn't mean you compute the percentage using that. Right? So make sure your notation properly reflects what you need to compute 12% of. So here's your interactive question. This is a challenging one, so do your best, but create two word problems. Okay, create a word problem. First, like your first word problem should have 20.00 plus 0.14 times 20.00 equals a as the relevant equation, and your second word problem should have a plus 0.14 times a equals 20 as its relevant equation, where a represents the final answer. So note how similar these equations look. They're both dealing with a 14% rate, and they both deal with the $20 dollar amount. And just try to challenge yourself to create two separate word problems. Sorry, it should say your first word problem, and then the next bullet should say your second word problem. So please try doing that. And this is a bit challenging.